What's going on, everybody? I'm Average Joe and welcome to another Average video. Today's Average video, you guessed it, we're going to be assembling another DIY battery, although this one is from BASENGREEN. And they also sent out 16 of their 315 amp hour cells. And I also did a little inspection when I was taking everything out of the boxes, and I will be happy to report that I didn't have any damage whatsoever, which is kind of unheard of these days. And final note is Mrs. Average Joe's not going to be here to assemble this battery. You're going to be stuck with this guy. Just a quick little overview of the front of the battery. So of course you're going to get two positives and two negatives with M8 bolts. Right in the center you're going to get a big old ka-chunky DC circuit breaker right here. I believe it is 200 amps. Right below that you're going to get a on and off button. Right over here you're going to get your screen and a couple of buttons which will give you kind of basic battery information. Right below that you're going to get your state of charge, LED indicators, alarm and run indicators, some addressing dip switches, a reset switch, a CAN/485A port. This is going to be for communicating to your inverter. And then you're going to get an RS-485B and C port right here. And these are going to be for battery communication, you know, one battery to the next. Then this little funny looking knob right here is going to be for like a Bluetooth range extender. And then finally a little tiny ground screw right here. And I believe inside the box is going to be two foldable or collapsible handles that we can attach to the front right here. And then we'll take a quick look at the cells. So these are 3.2 volts nominal lithium iron phosphate cells, of course. Capacity is 315, 1008 watt hours. The internal resistance, at least at the time that they checked it, was 0.2 milliohms, and then the model number is 315 amp hour. And if we scan the QR code right up here on the top, we actually don't get too much information. Manufacturer is Envision, which I'm guessing is more probably like a house brand. Doesn't really give me too much more information from there. Number of cells produced, 16,248. This is gonna be your top view, so positive, your expansion or explosion port right there, QR code, and then your negative right here. I took a look at all the cells, of course, and I didn't see any damage or anything crazy whatsoever to report. The bottom of the cells do have the black plastic on the bottom, so nothing's going to rub through. So yeah, there you go. There is the Envision brand cell right here. And inside of those 4 boxes, we did get a set of bus bars for each 4 cells. And then we also got 4 of these epoxy boards in each box. One last thing that was in the box on top of every single cell were these little battery covers right here, so nothing could potentially short out. So I have a whole bunch of these guys. Oh, get out of the way. First thing we got to do is remove the lid on top of the battery. We got 3 screws right up here on the top front, 5 along each side, and then 3 more on the back. And these are a number 2 Phillips head screw. Bottom of the lid does have the epoxy board on there. Looks like we do have more epoxy boards on the inside. So the ones that came with the batteries, I'm not sure that we'll need those, but we'll find out. So gonna get the long ones and the short ones. And then there's another bag right here, which we can't get out quite yet. We need to remove these 2 braces right here. These are actually labeled 1 and 2 right here. So we do need to remove those. That's going to be the balance lead connectors. We'll get those out of the way. Those are number 2 or probably a 10 millimeter. Oop, lost that one. Remove him, and it does look like they have the EV foam on the bottom. Number 2. Now we can get to that bag. I took everything out of that bag, so we're going to get a couple of pieces of EV foam, 2 of these are thicker and 2 are thinner. We're going to get 4 battery terminal covers. We're going to get a new set of bus bars right here, which I thought were going to be the copper flexible bus bars, but they are not. They are actually just aluminum bus bars. They do look really, really nice, but they are the rigid style right there. We're gonna get 2 of the foldable or collapsible handles for the front of the battery right here. You're gonna get 4 M8 bolts for the front battery terminals, a whole bag of serrated flange nuts, 2 fire extinguishers, USB to Ethernet communication cable for battery to computer, a longer Ethernet cable. This is probably for inverter to battery, and then what looks to be like a DIY style Ethernet communication cable right here. And then finally the 2 brackets right over here, so you can mount this into a server rack if you have a server rack. We are going to have to pull off this front cover as well, so there's 2 more screws on this side, on the other side, and then there's going to be 3 screws on the bottom. Boom. Just like that. Okay, so we do have the active balancer connected, so we do have to disconnect that one. There we go. We can set this aside for right now, like right here. And behind that front panel, we have a 5 amp active balancer right here. And if we back out just a little bit, next step, oh, there's that screw that I lost. All right, next step is gonna be removing or loosening these 6 screws right here. This is gonna be your front compression plate or fixing plate. I'm gonna try to just loosen them first, and if I need to remove the entire panel later, then I will. All right, this is everything out of the box. Let's get to it. I didn't find a manual or anything like that to put this together, but I remember seeing on the front of the battery right here, they have a QR code right here that you can scan for the manual to put it together. Alrighty, never mind, the QR code doesn't work, so I will have to get in contact with them to see what's going on with that. First is going to be all the epoxy sheets. 2 of them are going to go across the bottom. The other 4 are going to go on the sides. Next, the lighter color are all going to go in between all the battery cells. And then we have 4 that are a little bit darker and they have some cutouts in it. Those are going to go on the back and the front. But we also need to attach the EV foam to those. So the 2 thinner ones right here, I think I'm going to put towards the back. And then the 2 thicker ones, I'm going to put right up here on the front. All right, next is going to be all the battery cells inside the case. So according to this little PCB board that went across the top right here, right over here is B15, so number 16 is going to be right here on this red wire. That's going to be our main positive. So I'm going to put my main positive right here and then the main negative on this side. So once we stick in the first cell, positive is going to be right here. Then we're going to alternate the cells back and forth all the way down to the end. But whenever we put a cell down, we're going to put a cell separator in between each battery. Cell number 1 with these cells, the black is going to be the main positive. So we will set him in here. Oh, we don't want to slide that bottom thing too far. Slide him up to the front and put a separator in there. We'll grab the next battery and then we will alternate it and drop that in here. So there we go. We have a positive, negative, and we're going to do that all the way down. Cell separator, next cell. And here's where it could get a little tricky if I need to remove this front plate or not. I don't think it's going to fit. Now we'll slide those forward just a little bit. Okay, now we do the same thing for this side. Next, we're going to put these screws back in. Ooh, I don't know if we can do that. I am running into a slight problem is these bolts are actually too short once you have on the EV foam. All right, I pulled out these ones because it's just way too tight. I'm gonna see if I can pull off the EV foam and just put in the piece of epoxy board all by itself. And hopefully these aren't stuck on there too much because it's all brand new and it wasn't compressed really at all. So if I can get these off, that would be fan-freaking-tastic. If I can't, then I'll probably just put like 1 or 2 of the ones that came with all the batteries. It's got a little tiny tapey stuff right back there. That's going to be fine. I'll put it on the outside. Boom, we'll just slide that right in there. Boom. Same thing, I'll just put the tape on the outside. We will slide that right down in there. It probably really doesn't make that much of a difference, you know, whether we use these pieces of epoxy board or the ones that came with the cells. And we'll tighten down these bolts. Next is going to be the top support rail that has the balancing PCB board right up on top. This one is labeled number 2. It's going to go on the right hand side, or at least that's where it came from whenever we took it apart. We just have those 4 screws. For these top rails, you do have to make sure they're in the correct orientation with the correct PCB. So what it tells you to do is look at these numbers right here. I know you can't really see a lot of it because it's got glue on it, but we're looking for B-, B1 all the way to B8, and then we have NTC1, those are your temperature sensors and stuff. We have 1 and 2 on the bar that's on the left, which right here they have it labeled number 1. And then on the other side, if we look over here, all of these numbers go in order according to the cells. And then we have NTC3, ground, and then NTC4 for temperature sensor 4, number 2. Okay, so we just need to make sure that those are in the correct orientation. One last thing I forgot to do before we put all the cells in here was check the voltage to make sure they're all the same. So that's what I'm gonna do real quick. 328, 328, 328, 328, 328, 328, 328, 328, 328, 328, 328, 328, 328, 328, 328, 328. Nice. Next is going to be placing down all the bus bars into position. We have our main positive right here, main negative right here. So we're going to go right here, 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 here. We're going to cross over and then do the same thing. We'll go 1 here. 1, go over. Finally, right here. All right, now that we have all the bus bars, the next thing we're going to do is install all of our balance cables, and those are going to go to 1 bus bar basically on each side. If you look on the board right here, you can see a B1, that's basically battery 1, and that's going to go on this bus bar right here. The next one over is B2, so it's going to go over to battery, technically battery 2, but you can put it on either side of this bus bar right here, and it's going to go all the way around, okay, all the way back up here to the last one. It doesn't say B16, but it'll be this red wire right here. This is our main positive. But there is one thing that we want to make sure is on these ring terminals for the balance wires is we want to make sure the heat shrink is back far enough so whenever we put on our flange nuts right here, the heat shrink does not go underneath this backside. You know, once it's actually installed, we want to make sure that the heat shrink is cut back far enough so we make good contact and connection between the battery, bus bar, and this ring terminal right here. So B1, again, it can go on any location on this side over here. I wish there was actually like a location on the side of the bus bar where we could attach these to their own screw, but they don't have that for this option. This is what we got. So I am going to make sure that the nut will go all the way down. It's really, really close, but it does not touch. All right, trying to get this down as close as I possibly can. If you look at that heat shrink, it almost goes underneath the shoulder of that nut. If it was any closer, what I would have to do is trim that heat shrink back. But this one is super, super close. I think it's gonna be okay. But that's what we're looking for whenever we install the balance leads and the nuts. All right, now that those are on, we're going to torque down all those nuts down to 6 Newton meters. Except for the main positive and negative right here. We'll do those in just a little bit. All right, next thing is going to be the front panel with the BMS, but before we do that, we do have to install the flip out handles right here. So they're going to go in from the front side. They're going to back out right here, and then you can tighten down the nuts. But before we do that, I was just going to take a quick little look over of the BMS, and I'm also going to check the tightness on basically everything in here. And we're also going to make sure that the heat shrink is not too far on the back side or on the front. Basically in all of the connection points right there, which I'll have to take a look at that just a little bit better to make sure the heat shrink is not stuck in there, which it could be. This side looks okay. See how it's sticking out a little bit? And I'm going to check the tightness of all of these up here as well. But here is the BMS right here. This is most likely the pre-charge resistor. Yeah, I don't really see too much on there that I would really know anything about. If you want to see the part number, KS48200-H021_V2. Doesn't really give me too much, but it's probably, again, like their house brand or probably like a Pace BMS. Okay, and then like we already mentioned, the active balancer is going to be right back here, which actually, after we get our 2 little handles on here, and when we put this on, we're actually going to plug that in first and then attach the panel to the front of the battery. So I'm probably just going to have my handles fold outwards like that. Pop them on there, put on a lock washer and a nut. And these are a 14 millimeter. I'm gonna check the tightness of all of these. That's tight, 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 tight.
Oh, tight, 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 yeah!
Okay. So this one right here, okay, so that is not underneath it anymore. It was just barely underneath that little tiny edge, so I'm not going to take that one apart. But I do want to check the mounting bolts right up here, and those are probably a size 10. That one's tight. That one's tight. I have to loosen this one to check the other one real quick, which is okay. I'm fine with that. That one's tight. And we'll oh, actually, you know what? I am not going to do that right there because there's the heat shrink on this bus bar that's kind of in the way. If I can leave that sitting out like that, I am going to do that. We won't know that until we install it on the front of the battery. I'm not going to tighten that one down yet. Okay, that is pretty much it. We can go ahead and put this on the front of the battery. We're going to plug this into the active balancer real quick. So according to the video and their installation instructions, you do the big one first and then the smaller one right here. I don't have any magic smoke or anything like that, so then we can lean this up and just make sure we don't have any wires caught underneath or anywhere like that. Next, we can put a couple screws in the side to hold the front panel up. And don't forget about the ones on the bottom. All right, now we can work on our main negative and our main positive. First thing we're going to do is start with the negative because it is the lowest potential. We'll set him on there along with the balance lead or the negative right here. Install our nut. Actually, you know what? I need to trim back some of the insulation on this one. Not much though, it's just barely too big. Go ahead and tighten this one down, torque it. And then finally is going to be the main positive. So we're going to need the main positive cable. We're going to need the BMS power wire right here. And then finally the balance lead right here. No magic smoke. And I'm going to go with the balance lead and then I'm going to go with the BMS power on wire right there. I did hear a beep and then the screen turned on and then turned back off. Technically we could have disconnected it right here, but we don't really need to worry about it now. There's one thing I forgot was to tape down the temperature sensors. There's a total of 4. You got one here, one here, one here, and one here. I don't have any special tape for that. I'm just gonna use this tape, whatever kind of tape this is, as long as it sticks. Next one will go right about here. This one right up here, I'm going to tuck it underneath these 2 balance cables and bring it right up here towards the front, because that's what they're showing right there. Tape him right about here. All right, like I said, I wanted to adjust this negative right over here, so I'm gonna put it straight out so I'm not underneath any of the heat shrink. Tighten him down, and I might adjust the positive over here as well. We'll go right there. All right, the last things we got to do is plug in our balance cables right here. And again, this is very important. You always want to start with the lowest potential first, which is B negative. And I don't think you can technically mess these up, but if you're unsure, you're just going to match the 1 to 1, 2 to number 2. Put these wires kind of down below. All right, well, here goes B1 first. Make sure it's all the way in. No magic smoke. And then B2. Boom. No magic smoke. And I think that's basically it. Alrighty, we will turn it on for the very first time. Here we go. No booms. Okay, heard a little tiny beep. Our screen is on. I do leave the camera further back whenever I turn things on for the first time, just in case something, you know, happens, I can catch it all on camera. Just for you. We got 52.6 volts, 63% state of charge, which I'm not sure if that's accurate right now or not, showing 197 amp hours left in the battery. I'm guessing this is maybe the inverter, and this is probably how many amps we're using. I'm not sure what those dots are right there. Anyway, we will hit menu button. So we got BMS parameter, we got voltage, current, cell temp, cell volt. We could take a look at those to make sure they're working, which that one is. And then if we want to see the cell voltages, which we already looked at previously, all sitting at 3.294. So there we go. And that's pretty much it for this screen. We'll back out. Gyro status, I'm not sure what that is. I don't really think I should be messing with a gyro. And then version, BMS version, we can see that, 2.2.2. Here's our BMS hardware version, etc. LCD version. Okay, can we change anything? Oh, there we go. That's what I was looking for, is the CAN and RS protocols. You can just cycle through these. I'm going to be using the LXP because that's what I have for Lux Power, but there is quite a few in here. Okay, so I am going to set mine to Lux Power right there. I don't know if I have to do anything else. And then if you want to see the RS45, again, a whole bunch of different things in here. Oh, just 4 in here. Okay, well, that is going to be our screen right there. Alrighty, we're almost finished. Next thing we got to do is put on our little fire extinguisher. Snip like that. Peel that off. Peel this one off. And we will tape these into place here, here. Boom, just like that. Now all we need to do is put the cover back on the battery. Now, if you really wanted to, you could install the server rack mounts right over here on the side. Basically, you're going to pull out the screws that are in there and then put them through the bracket and put it back on. I'm not going to do that because I don't think I'm going to need these. Boom, there we go. Now it's up to 10.4, which is what that charger can do. Next thing we're going to do is check out the Bluetooth app and then probably, if we can, the PC software. We'll open. Maybe we'll just hit the search button, allow while using the app. allow. There we go. We're looking for this one right here, which is on the code right down here. Okay, so since I've never seen this before, I'm not 100% sure what we're looking like, but 63%, which matches the front right up here. Estimated time discharge doesn't really give us anything. Estimated remaining charge time is 11 hours and 9 minutes, but we're only charging at 10.3 amps, which you can see right in the center under battery status. So we have voltage, current, power, temperatures, and then the system status, which we are charging right now. We can see our minimum and maximum cell voltages right below that. So max is 3.317, lowest is 3.309. Okay, what else can we do on here? Historical data unlock. Oh, password. I haven't seen anything for a password yet. Okay, so I clicked on the little gear icon down there, so this gives us a little bit more information for balancing state, etc. It's in the closed state, unprotected. I'm guessing because, nothing is on right now. State of charge, MOSFETs are on, temperatures, and all that kind of stuff. Okay, cell voltages, that's cool. We can see every single one in here, which is good. Change the language, which we don't want to do. Fault data, please enter the unlock password. I'm not sure what that is. It's probably in the manual, which I still have to download. I'm just gonna guess real quick. That's the wrong password. Okay, so I will come back to that. Okay, well, I guess I probably can't do a whole lot in here. Okay, so I will let this charge up a little bit, and then I will get the computer interface up and running. All right, next what we're gonna do is check out the PC software. So I went to the BASENGREEN website, and I went to the download center, and then right over here on the left-hand side, you can click on software, and we scroll down to the version 3 software, and we just download that and then install the program, the BMS tools basically. And then we're going to use the USB to Ethernet cable right here. We'll plug that in right there. And then we're going to go into the CAN/485A port right up there. Real quick, whenever you first install this, it's going to be in Chinese and you're not going to know what's going on. All you're going to have to do is go over to the screen on the left hand side and go down to the bottom option. It'll have like a set of headphones. That'll be the picture that you'll be able to make out. You'll click on that. It's basically the help section, and then you're going to choose your language right up here. Back to the main screen. The next thing what you're going to want to do is look at your dip switches on the bottom of the battery. All of mine are in the down position, which is 0. You need to make sure that is set up over here, and you also need to select your COM that you're using, which is my USB. It's COM 5 on mine right now, and then it'll all start magically working. All right, so this is going to be the computer software. If you don't like Bluetooth apps and stuff like that, this just gives you another way to kind of monitor everything and possibly even change some settings, but we will find out. So obviously this is going to be our main screen. On the left hand side, you can see basically it's showing all the cell voltages inside, and it also shows you the highest and lowest cell. You can see it in the green and orange, and it's changing as we charge the battery. Right next to that's going to be our state of charge and state of health. We are currently at 70.03% state of charge. If this is accurate, since this is like the very first time we're charging it, we're not really sure on that quite yet. Right below that is all the BMS information: 52.28, 10.36, and 552 watts. Again, it's going to show your min and max voltages right below that, and then right in the center is going to be your cell delta, and we're kind of hovering between 9 and 11 millivolts, which is pretty good for right now, but we are still kind of low. We'll find out once it gets a little bit higher, or at least at the higher end, to see what it's really at. I would imagine it would be out since this is the first time we're charging it. Right below that, obviously you can see we have 0 cycles on this battery so far, and then our average voltage is 3.3 volts. Bus voltage and bus current, both of those say 0. I'm not sure what those actually mean quite yet. Maybe that's if we're actually connected up to a inverter, it might show us voltage from the inverter. I'm not sure, we'll find out a little bit later. And then we have all of our temperatures right below that. On the right hand side, we have system information for our MOSFETs. The charging and discharging MOSFETs are turned on and we are charging. I would imagine the other ones will light up if that's what was happening right meow. Protocol options. Let's see what happens. Oh, okay, so basically you just select your port that you want to see, and then you can probably change whatever protocol you want to use. I already set the Lux Power protocol, but if we wanted to change it, you would just select it and then hit the set button, is what it looks like. Right below that we have alarm status, protection status, and fault status. None of those are active right now. And then if we scroll down a little bit, you can also get real-time data, and it takes a little timestamp and it'll give you all that information right through here. Looks like it gives you basically everything that we just looked at right above. Okay, it looks like you can export that as well if you want to. Over here on the left hand side we have a drop down menu for parameters, and maybe if we hit get all, it'll pull all that information. Yes, it did. All right, so this is everything that's programmed into the BMS. Starting with the cell voltages, we have the discharge protection is set for 2.5 and charge protection is 3.65. I think that's pretty standard. Right below that's going to be our charging temperatures and protections. So low temperature protection is set for 0, which is exactly what we want. We don't want to charge when the batteries are freezing. High alarm is set for 55 and high protection is 60. Total voltage over here on the right hand side, discharge protection, it looks like it's going to shut off at 40 volts, and then charge is 58.4. That would be 3.65 volts per cell. We have the current level below that, so discharge protection at 215 amps. Okay, this is a 200 amp BMS inside. You will get an alarm at 200. And it looks like the same thing for charge. And then there are some other parameters right here in the lower center. Constant voltage, constant current, cell sleep delay, starting voltage, that's going to be whenever we start balancing, and it was already set to 3.45, which is fan-freaking-tastic. Starting voltage difference, set for 30 in here. I wonder if I can change that. I don't know, I'm going to see if I can change it. Set all. Ooh, password. 1, 2, 3, 4, 5, 6. That was 6 number 8s. Incorrect password. Okay, I don't know what the password is. I will see if I can get that and then maybe flash that up on the screen a little bit later. Okay, anyway, back over here on the left-hand side for settings, we have system settings, basic settings right here. We'll hit the get button. Oh, okay, so 16 cells, remaining capacity, full capacity, design capacity, etc., all of that kind of stuff. BMS information, sleep settings, BMS information, get time, that's the current time right now, and then records. Oh, maybe they throw these BMSs in like a test machine. Cell over voltage count is 115. I'm just assuming that they test out these BMSs before they send them out, because this is obviously the first time I've had this connected, and I haven't had any over voltage counts yet because we haven't even hit full charge. Okay, and then there is a calibration area right here. I'm not going to touch. History, and then maybe an upgrade. I guess maybe if you have a upgrade file, you could potentially upgrade everything from there, and I think that's basically it. Back to the monitoring page. This is probably the page that you're most likely going to look at if you don't want to see a phone Bluetooth app. Okay, that's just a quick little overview of the PC software. And I did what I mentioned real quick. I did figure out the Bluetooth app password. It is 6 number 8s. The way I figured that out is I went to the message parameter set Wi-Fi and I just hit 8 6 times. I hit confirm and then it worked. So I don't know what this is for the Wi-Fi stuff. Maybe you can see this through Wi-Fi, you know, and you don't have to be, you know, within Bluetooth range. I'm guessing what that's for. We can also go to the system parameters, and that's all the stuff that we just looked at inside the computer app. Okay, so this just makes it a little easier to see, you know, on your phone if you would want to see all of that information. I wonder if I could change these. Here it is, here it is. Balance open voltage differential. I wonder if I can change that to 0.1, which would be 10 millivolts. Let's see if I can confirm that. Parameter setting succeeded, so I think I did change it. I just lowered the differential down to 10 millivolts. So we can change the settings in here just fine. I just don't know the password for the computer app yet. Alrighty, it is the very next day. I left the charger on it all night in hopes that it would be fully charged and fully balanced out today, but it's not. All right, this morning when I came down here around 7 o'clock a.m., I saw that it was technically full charge right up here, but we could see all of the balancing and all that kind of stuff happening over here, and the charging had stopped. And if we look right here, the cell delta is 254 millivolts. I think this morning I saw as high as 290 something. So we are not balanced out. We have quite a few cells over here. Hopefully it's in focus. It looks like cell number 4 and cell number 2 are like the highest right now. And then all the rest are around 3.39, 3.8, you know, stuff like that. They're all pretty low. So we are not balanced whatsoever. So then I brought out this charger right over here and put a 5 amp charge on it in hopes that that would kind of help balance everything out, since this does have a 5 amp active balancer in it. But that didn't happen. Basically cell 2 and 4 were still doing the same thing, and then we would get a cell over voltage alarm, and then the protection would kick on and it would stop charging. Okay, so then I lowered it down to a little over 1 amp in hopes that I could basically keep it running, and I'm still having that problem. So I'm not actually sure if the 5 amp active balancer is on. So I just pulled out all the screws on here, and we're going to take a look at the active balancer real quick. If we look right back there, we can see the 5 amp active balancer. We do have a blue LED light on, but it's really all I can see back there. I don't really know if it's actually working or not. We're going to put a clamp meter around some of these and see how much power we're drawing to see if we're actually doing anything at all without breaking it. That one is doing a little over a half of an amp right there, and I'm not gonna move the camera every single time. I'm just going to read them off to you. That one is not really doing anything. It's 0.07, 0.06. That one is the same, 0.06 to 0.08. That one is doing 1 amp, so this is cell 4. So we are doing 1 amp on that one. I don't think I'm going to check any of the other ones because those are really the only 2 that are high. So I don't think anything else would be going. So I'm thinking the max that I can do per cell is basically 1 amp. What I'm going to do to speed up this process is I am going to drain some energy out of cell 2 and cell 4. And this is something that you typically wouldn't have to do. You would basically use the battery and it will eventually balance itself out. But I want to do my capacity test basically right now, so I'm not wasting a day doing nothing. All right, sorry we are looking at the computer screen, but our cell delta is 16 to 17 millivolt difference, and our voltage is sitting right now at 57.91 volts. Now that we are balanced out, I'm gonna put the cover back on, we'll take it over there and we'll do a capacity test. Alrighty, got the battery hooked up to the EG4 6000 XP, and we're gonna be going through that and then into the eco-worthy charger right here, and we're going to be dumping the battery capacity from the BASENGREEN battery over to my battery bank over here at a 0.2 C rate, which is around 63 amps or so. I got the BOOM shunt hooked up right here. Right now we're sitting at 57.17 volts. I have the battery capacity set in here for 315 because that's what the cells are. I have gone into the history and reset that. So all we need to do is get this party started. So we will flip that on. Now we're going. We're doing 55 amps on the eco-worthy charger. And if we want to take a look at the front of the battery to see what that's doing, on here we're showing 66 amps. All right, 63 amps is close enough for me, so test has started. at 2:40 p.m. and I will come back in roughly 5 hours. Give me just a second and I'll be right back.
5.
We're getting down to the very end of the first capacity test. Right over here we're showing 1% left, 47.9 volts, 73.3 amps, 3,500 watts. Max and min cell voltages, so highest is 3.05, lowest is 2.837, and our cell differential is 214 millivolts. We do have a low battery alarm, so I think the inverter is going to shut off around 42 volts, so we still have a couple of minutes left. And if we take a look at the old BOOM shunt, if this is accurate, we have done over the advertised 315 amp hours. We're at 317 right now, or 16.3 kilowatt hour, and still going. I wonder if this is going to be the biggest battery and capacity that I have. That's cell delta, 435 and climbing. Okay, we got 320 amp hours, which is 5 over the advertised 315. And we also got 16.4 kilowatt hour, not too bad. If we take a look at the screen here, you can see our cell delta was around 480, maybe even 500 millivolts, which is pretty high. Obviously, cell number 2 was the culprit. Cell undervoltage protection basically kicked in and cut us off. All right, well, I don't really know what else to show you from here, other than the highest cell is still at 3.062. A lot of them are still pretty high. So the interesting thing is the first 4 batteries, cell 1, 2, 3, 4, those were the highest voltage cells whenever I was trying to balance the entire battery pack out, and the rest of those were down, pretty low. So now it has completely flipped. All right, well, I'm gonna get this charged back up and we'll go again. Do you know what I'm gonna say next? Well, if you said boom, it is the very next day, and we're getting ready to do a full send test on the BASENGREEN battery, then you would be correct. So behold. All right, starting off with the BASENGREEN battery right here, we're sitting at 100% state of charge. It actually says 327 amp hours. So I'm guessing this might actually recalibrate once you do a full capacity test. Anyway, from there, we're going up to the Lux Power 12,000 watt hybrid inverter, and then from there we're going to a little tiny sub panel. The only reason I need that is because I need these 2 L1430s right here so we can use the EG4 charge inverter and eco-worthy charger right there. So basically what's going to happen is we're going to discharge the battery capacity from this battery and disperse it throughout all of the other batteries behind it. But wait, there's more. I also have the BOOM shunt connected. I have the history reset, so everything is good to go there. And I also have the battery connected up to the PC software right over here, so we could take a look at that if we really wanted to see that. So in order to have this, I do have that connected into the CAN RS45A port. So that means we can't use communications on the inverter for right now, but that's okay. We'll just use the lead acid settings. Now keep in mind, this test really isn't a capacity test. It's more of a full send test. So see if we can actually pull or draw 200 amps or close to it all the way down to 0 without stopping, unless I mess it up somewhere and have to start it over again. But other than that, we're just going to full send it all the way down to 0% state of charge, if it'll let us. Okay, so I think all we need to do now is turn everything on. So that is on. Turn on our chargers over here and right here. I'm just gonna full send the EG4 charge inverter, and then I will adjust the eco-worthy so we're kind of around the 195 mark. And then once I get a little bit lower, I will have to lower the eco-worthy one just a little bit so we can stay under that 200 amp so the BMS doesn't shut us off. All right, now it's gonna get even louder with more fan noises. And this will probably take a second for it to get going. Boom, there we go. We're up to 194 amps. And on the BOOM shunt, we're showing 188.74. Right up here we're showing 194, and if I bring out my meter, it's showing 197. I don't know if you can actually see that or not. So the amp rating on the battery is just a little bit closer to the amp reading right here. Okay, so I will let this go as long as it'll go, and I will be right back.
Later.
Alrighty, getting to the bottom of this full send test. According to the BOOM shunt, we have 3% left. We're drawing 187.5 amps or 9,115 watts. We have 3 minutes left, possibly. We have discharged 305 amp hour or 15.3 kilowatt hour thus far. If we take a look at our PC software, right up here at the top, we're showing 3.28%. Battery voltage is 48.9. That's kind of what we're looking at. As soon as we get down to 42-ish, it'll shut off unless one of the low voltage cells cut us off. Doing 197 amps or 9,625 watts according to this. You can see cell number 2 is going to be our lowest at 3.013. Cell 16 is the highest, 3.091. Our cell differential is 83 millivolts. And if you want to see temperatures, it looks about the same as before. 81C for the MOSFETs. Environmental is 45, and then the rest are 42, 45 degrees Celsius. We have a low battery alarm, and we still have the cell overvoltage alarm in here. It has not cleared itself quite yet. I'm not exactly sure why. Typically they do. So we're doing 198 amps. I'm actually going to lower it down a little bit so we can continue the test. State of charge is definitely going to sit at 1%. Oh no, it just literally lowered down. Okay, so now we got our low battery alarm, and now our state of charge is at 0%. Look at our cell delta right in the center. It's at 427 and rising. Yeah, we're gonna shut off any moment now. There it goes. Screenshot, screenshot. We got 321 amp hour, 16.1 kilowatt hour. Our cell delta got up to 490 millivolts difference. Cell number 2 was the culprit. Alrighty, I would say that was a pretty successful test. We actually got 1 more amp hour than the previous test, which was 320 amp hours. Okay, there we go. Cell undervoltage protection. I don't really know what else you need to see on here. I would say we did fan-freaking-tastic. I'm going to get this recharged, and I'll see you in a second. All right, one thing I want to mention real quick, as I was pulling off all my battery cables, you could feel the battery was quite warm. It's only been about 2 minutes since I got the camera back out, and I was just going to give you some temperature readings if this will focus. If you're looking at the top of the battery, we're sitting at 105, 106 degrees Fahrenheit. The highest I'm seeing is 111 right in the center. It's like right here where the circuit breaker is. That's showing 127.3 degrees Fahrenheit. So what I'm gonna do real quick is, it's gonna take me a second, but I'm going to pull off the top here and we'll take a look inside. All right, obviously it's been a couple of minutes so I could get all this taken apart. If I look at the circuit breaker, it's showing 155. So it could have been just slightly warmer. That's going to be this side. The other side is showing 146, and I'll just kind of scan around. Just the top of the cells are around 115, 116. So the top of the cell right here, 116 to 118 depending on where we look. The bus bar on the heat shrink right here, 115. Checking this terminal right here on the heat shrink, that's 146 degrees Fahrenheit. This one is 125. Coming off the main battery, 110, 110. Yeah, everything's not too bad in here. 122 on the negative. So the hottest things in here is probably going to be this DC circuit breaker, BMS board and stuff down there that I can't really see very well. So overall, it's not too bad. Just the circuit breaker up here is pretty warm at 140 degrees. Alrighty, I'm gonna start wrapping up this video because I'm sure it's gone on long enough. I just wanna make sure everybody's on the same page, you know, whenever I build everything and how I test everything. That's why it takes so long. Alrighty, overall, I would say the battery did fan-freaking-tastic. The build was easy to do. The testing, I mean, running it at basically 200 amps for almost two hours, I think that's pretty damn good for basically any battery. So this one did fan-freaking-tastic all the way from 100% all the way down to 0%. Without a problem. Anyway, overall, it did fan-freaking-tastic, but I do have a couple of suggestions that I would change or do, and that would be for Basen and or for you guys if you do decide to purchase this battery, okay? And these aren't really in any particular order, it's just some things that I took some notes on. The first one is for the EV foam. Whenever I was building the battery, I put it on the front and the back. The thicker stuff was on the front, and then whenever I tried putting on the front compression plate or fixing plate, the bolts that you would attach all of that to were just too short, and if they were longer, you know, and I could put it in there, I would probably end up like putting too much pressure on the batteries. So I pulled the thicker foam out and just put in the epoxy board. Now I'm not 100% sure on this because I didn't ask, but I'm assuming since you can get different cells for the battery, they might be slightly thicker or thinner. You know, you just have a couple options with thicker foam and thinner foam. I would actually recommend them sending 2 more of those thinner pieces of EV foam. That way you can have thin foam on each side. You don't technically need the foam there on both sides, but I guess it would be nice. I know in a lot of DIY builds and stuff, we don't even use foam. And then the next one is whenever you're assembling it for all the ring terminals on the balance wires, you need to make sure all of the heat shrink is trimmed back far enough. It would be kind of nice if Basen would do just a little bit better for quality control, making sure there is enough room, because whenever you're assembling this, you know, you're going to set it on there and then you're going to find out it's, you know, you got to trim some heat shrink, and that, you know, it just takes up a little extra time. So if they could make sure all of those are trimmed back and perfect, that would be fan-freaking-tastic. And then the other ones would be on the front plate where your BMS and all that kind of stuff is. You need to make sure all of those are cut back as well. I would also suggest making sure everything was tight. Even though I had everything that was tight, I did have a couple that I adjusted whenever it was finally put together. So just make sure all your heat shrink is trimmed back enough. The next one would be, it would be really nice if they included the flexible bus bars. Flexible bus bars are just the bee's knees these days. And then a little cherry on top would be having the little nut plate inserted into the bus bar. That way you could attach your balance wire to that and not putting your balance wire on top of the battery post, you know, because whenever you tighten down your serrated flange nut, it has a tendency to rotate the wire. You know, you just have to, it just makes everything a little bit nicer and easier to put together. The fourth and final one is I had 4 cells that were shipped at a higher percent state of charge than the other 12. Now, it's not really that big of a deal because once you build the battery, you charge it up and then you start using it. Every time you charge the battery back up, it's going to eventually balance out all the cells. It would just be nice if all the cells were shipped at the, you know, really close percent state of charge. The next things aren't like a pro or a con really at all. I do like the PC software. You know, it pulls all the data really quick. You know, it refreshes quick. It's easy to look at. You know, you can see everything on the screen. If you type in the correct password, which is 6 6s, you can go in there and change settings if you need to. So I do like the computer app, and it does work pretty good. The phone app works pretty good as well. I'm just not a huge fan. I'm just not a huge fan of it. Same thing, it gives you all the pertinent information. You can go in there and change settings. Again, if you use the correct password, which is 6 number 8s. However, that does not work on the fault. Yeah, the fault data. Whenever you click on fault data, it'll ask you for a password there as well, and I tried all the 8s there and it didn't work. So the app does work. I'm just not a big fan of it. All right, that's pretty much it. If you guys are interested in this DIY battery kit, of course, I'm gonna have links down below. Now, they do have a few other options that you might have seen during the earlier part of the video. They do offer different cells like the EVE MB31s, and they also offer the JK BMS. So if you're a fan of those cells or that BMS, you know, that is an option. Of course, it is going to change the price, which let me get to the price of this one. It is, so if you got the same kit that I have right here with the Envision cells, or they're also called AESC cells, and the 200 amp Basen BMS inside. Right now it is showing $1,802 with free shipping. Now, of course, again, like I said, if you want the JK BMS or different cells, you're gonna have to get in contact with them so they can get you hooked up with a current price. And of course, I'm gonna have all that information down below as well. All right, that is pretty much all I got. If anybody has any questions, comments, or concerns, make sure you put those down in the comment sections. Or if I just completely missed something, make sure you put that down there as well. And finally, if this video is helpful in any way, make sure you like that smash button on your way out, and I will see you on the next. These ones do have the bottom plastic. If it'll focus, come on and focus. There we go. For computer